The general relative theory can be written by the Einstein-Hilbert action, but we can generalize these actions through with the additional high-order term. The Einstein-Hilbert action is given by the Riemann-Curvature term R, and the energy thrust tensors comes from the matrix Lagrangian. But this can be generalized to the functions of the Riemann curvature, so-called FR gravity. This contains the higher derivatives of the matrix rather than just a simple Riemann curvature tensor. R contains the second derivatives of the matrix in here. From the normal Einstein-Hilbert action, the equation of the motion is given by the Einstein field equation. But for the FR gravity, the equation of the motion is modified to the following form, where the FR is the partial F partial R divided by the pi, the scalar field as additional degree of freedom. And also there's F and FR in here. So the inside of the F, this means the coupling to the gravity of the other field of that or other particle. The well-known example of the gravities and the application is a Starobinski impulsion. Here the R square terms are considered inside of the function, the FR. This is the last mentioned chuck. And this R square term drives the impulsion. So the such a scalar field pi can be considered as impulsion field. And then from this F and FR and the second derivatives of F denoted as FRR, the perturbing terms of the scalar field has effective mass with the combinations of the FR and the FRR. But such a higher derivatives, higher dimensions of operators of the such FR gravity can be rewritten with the Einstein-Hilbert action with the coordinate transformation. This is called the exchanges between the Jordan prime and Einstein prime. In the Jordan prime, the Hilbert action part is the complicated, the form of the FR gravity. Some specific particle scalar field pi coupled to the gravity term R. This makes the effective Planck mass, this term, that varies over the time. But instead of that, the pros of the Jordan prime, the benefits of the Jordan prime is the matter action is a minimal, so the particle mass is a fixed. But we can rewritten the Jordan prime, the FR gravity, to the standard Hilbert-Einstein action by the transformation of the conformal scaling. The conformal factors can be chosen by the partial F and partial R. So for the Einstein prime, this action is given by the standard one, so the GR calculation is easy. But the method terms, inside of the method term, the matrix G used are now coupled to the matrix field. So the particle mass varies over effectively. So transformation between the Jordan prime and the Einstein prime can be applied to the various area, especially the Starobinski impulsion. In the Jordan prime, the action is given by the FR gravity, and as a technique, we can rewrite the term as this 1/2 m Planck scale omega square r, whereas omega is a conformal scaling factors, and these terms are cancel each out inside of the u, and keep that part. So the user defines like that. Then the first terms are just remain, so that we can obtain the standard Hilbert-Einstein action, and the second term can be related through with under the conformal transformation. G menu go to the scale factor scale times C menu, and the sum terms the total derivatives term, so that becomes the zeros at the proper boundary condition. And the volume element root of the minus c has omega minus 4 factor. So the potential V has omega minus 4 factors times the u. So in the Einstein prime, we can obtain the scalar potential. So action form becomes the standard one with just a simple R term, but the scalar potential becomes the complicated. So for the R case impulsion in the Starobinski impulsion, FR has the following form, including the R square term, and the conformal factors omega squares can be obtained by the partial after partial R. Then the relation between the scaling factors and the Riemann-Kurbachev term can be obtained algebraically, and by using the above formula for the potential, we can obtain the scalar potential in terms of the scale factors. And by giving the scaling factors from the canonical normalized scalar field pi, then the result of the scalar potentials in the Einstein prime, the R-scale impulsion has the following form. There's exponential minus pi m Planck. So for the large pi, the Riemann-Kurbachev is large, and the potential has a plateau, so the impulationary slow roll condition can be satisfied. So the point is in the Jordan prime, the action is given by the R-square term, but by the scaling transformation, the scalar potential can be obtained, and this gives the plateau potential, which gives the impulsion pictures. So this is the story of the Jordan and Einstein prime. Now I want to turn to the impulsion pictures, especially the Starobinski. We can calculate the several quantities of the impulsion scalar dynamics in this model. So again, the potential form is given like that. For the large pi, the potential is very flattened, and near the zero, there is a minimum. We can calculate the slower parameters first from the scalar potential. V prime the V, this is just the algebraics and the calculus level, so we can obtain the epsilon in terms of the parameters in the scalar potential Q in here. And also for the eta, the small epsilon and the small eta are required to satisfy the slow roll of the pi and the slow changing of the epsilon. So the V double prime, if we calculate this one, the results are following. So if we impose the impulsion and at the epsilon equal to the 1, then we can obtain the relation for the impulsion at the and the moment. Then we can calculate the effort of the impulsion integrated by the pi to the pi and Then the result, this is just also the algebraic calculation. Then the result is given by the e-board number and the initial build value. We insert this relation implant and build values at the end moment. Then the epsilon and eta, this term, such as simplified to the in terms of the e-board number. And for explain the inner impulsion, the e-board number is nearly e to the 60 members, and for the large n, the small epsilon and eta can be satisfied. And also we can calculate the scalar spectrum index nx and the scalar to the tensors right here. These two quantities also the importance in the impulsion theory, and this can be related with the eta and epsilon, and again in terms of sort of the e-board number n. So the Starobinski impulations model can be tested by the Anderson et al. So today we talk about the hypergravities and scaling transformation between Einstein and Jordan prime, and the application to the Starobinski impulations and the calculations of the several quantity.